From cow dung to electricity, each step transforms waste into clean, renewable energy, demonstrating sustainable technology at work.
Every journey to sustainable electricity begins at the source, fresh cow dung.
Farm workers manually gather fresh cow dung to prevent contamination. This raw material will later be
Mechanical scrapers assist in transporting large quantities of dung efficiently. This process ensures
Mixing dung with water creates a uniform slurry, which improves microbial digestion. The right consistency allows.
This heavy-duty slurry tanker truck arrives at the dairy farm, where cow dung is collected as the primary raw material for clean energy production.
Once filled, the tanker is tightly sealed to preserve slurry quality and prevent methane loss during transportation.
The loaded tanker now begins its journey, transporting organic waste from the farm to the biogas power plant. At the biogas plant, the slurry is unloaded into underground pits, marking the beginning of the electricity generation process.
After unloading, the tanker returns for another cycle.
In the pre-mixing tank, slurry is homogenized. Uniform particle size and moisture content ensure that
Pipelines transport slurry safely and efficiently to the digesters. Maintaining proper pressure and flow ensures Inside the digester, the slurry enters an oxygen-free environment where specialized microbes break down organic matter. Pumping the slurry efficiently avoids stagnation. Continuous movement ensures even distribution and prepares it for thorough pre-mixing before digestion.
The collection pit stores slurry temporarily, and agitators keep it uniform, preventing solids from settling.
Units. In the pre-mixer, water is added to optimize consistency. This creates the perfect environment for bacteria.
Monitoring pH and temperature ensures the slurry stays within ideal ranges. Anaerobic factory.
Operators fine-tune parameters, ensuring continuous optimal digestion. Even minor fluctuations can reduce biogas output significantly.
Slurry enters the oxygen-free digester, where specialized bacteria convert organic matter into methane.
The dome design efficiently collects methane at the top, ready for extraction. Digesters are sealed to maintain. Inside the digester, microbes break down cellulose and proteins, releasing methane. Methane collects at the top, while leftover solids settle. Efficient gas collection is vital for generating steady electricity output. Anaerobic bacteria break down cellulose and organic matter, producing methane. This biochemical reaction.
The microbes feed on carbohydrates and proteins in the slurry. The methane they release is collected for electricity production.
Methane collects at the top while solid residues settle. Efficient collection is critical for steady fuel supply to generators.
Methane exits through sealed pipes, heading to purification units. Controlled flow ensures safe and efficient handling.
Monitoring ensures methane quality. Only clean, properly pressurized gas can be used safely for electricity generation.
Biogas is purified to remove hydrogen sulfide and moisture. Clean methane prevents engine corrosion and ensures efficient combustion. Purified methane is stored in flexible balloons to maintain supply during continuous electricity production. Steady supply ensures generator stability.
Methane is safely transported to the biogas engine. Flow control prevents pressure spikes that could damage equipment.
The generator hall houses biogas engines that convert chemical energy into mechanical energy, the first step in electricity generation.
Safety valves release excess pressure, preventing accidents. Methane production continues steadily inside, ensuring safe, efficient operation.
External monitoring ensures the digester maintains optimal conditions. Every sensor contributes to continuous methane output for energy conversion.
Methane is highly flammable. Clear signage and strict safety protocols protect workers while allowing energy production to proceed safely.
Continuous monitoring of pressure, temperature, and flow ensures the microbial activity inside remains optimal for maximum methane generation. Collected gas flows through sealed pipelines. Controlled flow and pressure ensure safe transfer to purification units.
Biogas contains moisture and hydrogen sulfide, which must be removed. Purification prevents corrosion and ensures clean combustion. Filters eliminate corrosive compounds, leaving purified methane suitable for the engine. Clean gas is essential for reliable electricity generation.
Sensors confirm methane purity, ensuring only high-quality gas enter the generator. This maximizes energy efficiency and engine lifespan.
Purified methane is temporarily stored to provide a continuous supply. This allows uninterrupted operation of the biogas engine.
Methane is safely transported to the engine. Flow control maintains pressure, preventing surges that could damage equipment. Methane is safely transported to the engine. Flow control maintains pressure, preventing surges that could damage equipment.
The generator hall houses the biogas engines that will convert chemical energy into mechanical energy, the first step in electricity generation.
Methane enters the cylinders and ignition begins. Chemical energy is released as heat and pressure, moving the pistons.
Controlled combustion converts methane's chemical energy into mechanical motion. This drives the generator to produce electricity.
Piston movement translates methane energy into rotational energy. This rotational force will spin generator coils, creating electric current.
The turbine transforms rotational energy into electrical energy through electromagnetic.
As the generator reaches optimal speed, voltage and current stabilize. Continuous combustion ensures steady electricity output.
Voltage is regulated before grid distribution. Cooling systems prevent overheating, ensuring reliable, continuous operation.
Electricity generated from methane flows through cables to distribution panels, completing the conversion from organic waste to usable energy.
Transformers step up voltage for transmission. Electricity produced from cow dung is now ready to enter the grid for homes and industries.
The plant operates continuously, converting waste into renewable energy. Meters display the plant's output. Clean electricity derived from animal waste powers communities, reducing dependency on fossil fuels.
Continuous gas monitoring ensures safety and consistent electricity generation, maintaining optimal engine performance.
The seamless integration of digesters, pipelines, and engines illustrates the efficiency of turning organic waste into electricity.
Regular inspection and maintenance ensure safe operation, preventing leaks, and ensuring consistent power generation.
Even at night, digesters operate continuously. Anaerobic bacteria keep producing methane, allowing 24/7
Methane continues to flow steadily, feeding the engines and maintaining uninterrupted power supply.
Engines convert methane energy into mechanical energy even during off-peak hours, ensuring constant electricity supply.
Power is stabilized before grid distribution, maintaining safe, reliable electricity for downstream consumers.
Operators ensure continuous monitoring of methane flow, engine performance, and electricity output, keeping the plant safe and efficient.
Maintaining consistent methane pressure is critical to ensuring uninterrupted engine operation and stable electricity generation.
The integration of digesters, gas purification, storage, and engines enables efficient, renewable.
Higher turbine speed ensures maximum generator efficiency, producing more electricity from the same amount of methane.
Rotating coils in the generator induce electrical current, converting rotational energy into usable electricity.
Electricity flows from the generator to distribution panels, where it is regulated before entering the grid.
Green indicators confirm the plant is operating optimally, converting methane into electricity efficiently.
From collection to generation, every step is synchronized to maximize electricity output from cow dung.
Continuous monitoring ensures that methane flow, engine performance, and electricity output remain optimal at all times.
The integration of digester, purification, storage, and generation ensures continuous renewable energy production.
Mechanical energy generated from methane combustion is reliably converted to electricity with minimal loss. Electric current flows safely to the main panel, ready for distribution to the local grid. The distribution board regulates electricity flow, ensuring safe and stable power delivery.
Operators continuously verify performance, ensuring the biogas plant functions safely and efficiently.
Electrical output is monitored precisely. Proper voltage and current maintain reliable electricity supply for consumers.
Electricity generated from methane flows through cables to distribution panels, completing the conversion from organic waste to usable energy.
Electricity from cow dung is now ready for grid transfer, powering homes and businesses sustainably. Electricity generated is ready for transfer to local communities, powering homes and industries sustainably.
The control room oversees the entire process, ensuring stable, reliable, and safe electricity delivery.
Transformers deliver electricity at the correct voltage for transmission, completing the process from cow dung to grid-ready power.
Electricity from animal waste is now available for homes, farms, and industries, reducing reliance on fossil fuels.